Hello everyone, I am Shawon Saha. Peter and Reem are two of my teammates. We are 2021 NEREC Summer Fellows. Our research topic is impact of SMRs in global nuclear development. Our research question is to what extent will the global spread of SMRs increase the proliferation of nuclear weapons? Now come to the small modular reactors definition. Small modular reactors are advanced nuclear fission reactors that produce electricity of up to 300 megawatt per module, which is less than current power generation reactors. They are gaining popularity as a competitive low carbon technological component of future integrated energy systems, but some existing proliferation assessment methods are not well adapted for these novel arrangements. Now I will tell about the country's perspective for getting SMRs. Now I am going to tell about the SMRs considerations for newcomer states. What is the difference between SMRs and traditional reactors? SMRs are complementing variable renewable energy. Due to its modular size, it's easy to carry and can be placed into any remote locations. It requires less fuel and less active powered cooling systems than conventional reactors. High safety, less evacuation planning zone, long life, and low installation costs made it more appealing for the newcomer states. Now come to the problems of SMRs. There are some barriers for SMRs such as higher electricity costs compared to renewable energy, increased uranium prices, radioactive waste disposal, etc. Some countries have no technological advancement and poor knowledge about it, and some of them do not have nuclear authority also. Again, some countries' nuclear authority concluded that most SMRs are first of a kind technology and are still in the early stages of development. Most developing countries are afraid of becoming stooges of developed countries in political field.
Hi, my name is Reem and I will cover the impact of the global expansion of SMRs on the international regime. What is the effect of the global expansion of SMRs on the IAEA's continuity of knowledge? First, we are talking about hundreds of SMRs. As a result, IAEA will need more workforce and budget to establish safeguards. Second, dealing with non-compliance due to poorer governance, limitations of agreements, and sovereignty. Third, SMRs have innovative design features that may require new tools for safeguards. The definitions of proliferation resistance and physical protection that apply to most nuclear energy systems also apply to small modular reactors. For a given SMR system, analysts define a set of challenges, analyze system response to these challenges, and assess outcomes, and depending on that, we either increase or decrease safeguards measures. Safeguards by design is a concept that encourages the earliest possible inclusion of safeguards considerations in the design process of nuclear energy systems. It was introduced by the IAEA as a way of achieving safeguards goals with limited resources, for example, with the possible expansion of SMRs, and the most widely accepted assessment methods were produced by the two international nuclear energy development programs, the International Project on Innovative Nuclear Reactors and Fuel Cycles, and the Generation 4 International Forum.
Hello, my name is Peter Rautenbach, and I will cover the proliferation risks of SMRs in terms of security and terrorism. This comes in three forms, first being the global spread of the technology due to its relatively lower barrier of entry because of its reduced costs. This results in potentially multiple newcomer states to nuclear power, but these states have varying degrees of stability, expertise, and regulatory experience. In addition, this spread increases the chance of proximity to rogue actors and terror groups. Secondly, SMRs have inherently attractive nuclear material. This is because their sealed nature and long life often results in uranium being enriched to that closer to the 20% barrier, where it becomes highly enriched uranium. Even just close to 20% is 3 times easier to make a nuclear weapon. Finally, because of their perceived resistance to proliferation, vendors have been discussing cutting security staff by up to 80% for SMR reactors. All of this creates a perfect storm for proliferation, a global spread to places with little experience, and potentially more terror groups and rogue actors, the inherently attractive material of SMRs, and discussions around security reductions all come together to create a potential proliferation risks for terror groups and rogue actors.
Now, coming to the policy recommendation. For the state-based policy recommendation, one country should make a comprehensive framework on protection and emergency response between different countries. It will be good for closely situated countries. Also, they should develop domestic nuclear technology and regulatory competence. Choices of SMR's technologies, such as from which country they will take it, is very important. Regional safety framework for IAEA should be ensured. International collaboration about SMR's development is needed.
My policy recommendations for the IAEA safeguards. First, we should have global advocacy support for the IAEA safeguards to develop their potential and capabilities in line with the SMR's technology. Second, we should introduce new safeguards regulations, agreements, and tools that consider the new aspects of SMRs. Third, we should encourage research and development efforts to explore proliferation pathways from SMRs. And fourth, we should activate the role of organizations such as IMPRO and GIF to include more aspects of assessing the ability of SMRs newcomers, such as politics and regulations, and encourage countries to accept their evaluations.
In terms of creating policy to address the security and terrorism risks related to SMRs, the reality is that much of the risk can still occur even if international guidelines are met. Therefore, policy efforts should be set on assisting newcomer states to ensure a safe and smooth deployment of SMR technology. Therefore, to cover the risks we outlined before, global conferences with all key interests and actors involved with SMR should be held to guide this deployment. Key factors of the conferences should be the transmission of expertise, information, and even financing assistance to newcomer states to act as a sort of incentive to take part in the process. Additionally, however, the conference should outline UNSCR 1540 requirements and the importance of ensuring non-proliferation within their state. Finally, these conferences can act as a guide for the civil nuclear power industry on issues such as enrichment levels and facility security requirements to ensure that the risks are covered.